3-1, Josh, approach Charlie, down 230. Call 3-1, go.
Every day in the skies over hostile territory, squadrons of FA-18s are on the prowl. This is the front line where the FA-18 excels. Striking targets in support of troops on the ground and tracking the horizon for enemy fighters. These jets project power from thousands of feet in the air. And their reach extends to almost anywhere on the planet, because their home base is no ordinary airstrip. For the FA-18, home base is a floating runway churning the waters miles offshore. This is one of the United States' 12 aircraft carriers, a fully functional airport at sea. Even after striking targets and risking the threat of enemy fire, these FA-18 pilots can't rest until they bring their aircraft safely to a stop on board. A carrier air wing is made up of more than just fighter jets. Each of the 80-plus planes on board carries out a specific task. S-3 Vikings for refueling and sub-hunting. E-2C Hawkeyes for reconnaissance. EA-6B Prowlers for jamming enemy electronics. And HH-60 Seahawk helicopters for shuttling people and materials. All these aircraft and the carrier itself are focused on one objective: forward force projection. And the one plane best suited for that role is the FA-18. The FA-18 Hornet is a $38 million high-tech machine. It's the smallest plane on the carrier, just 56 feet long and 15 feet tall, with a 40-foot wingspan. Its streamlined design is characterized by a long, narrow fuselage and side-by-side powerful twin engines. At 21,000 pounds, it weighs half as much as many other fighter jets, with an advanced composite airframe of aluminum, titanium, and steel. To fly one of these jets is to join the ranks of just over 1,000 active Navy and Marine Corps Hornet aviators. The journey to become a carrier-qualified FA-18 pilot begins thousands of miles away from hostile territory in the peaceful farmland of Central California. Naval Air Station Lemoore is the Navy's newest and largest master jet air station. The flat terrain and lack of neighbors makes Lemoore a perfect spot. Here, aviators who have passed their basic flight training learn how to fly the FA-18. It's a mentally and physically challenging program. The newest class of trainees will undergo 300 hours of classwork and at least 300 hours more in simulators and training aircraft before they can even step into the cockpit of an FA-18 jet. Lemoore's Flying Eagles of VFA 122 are among the best in the Navy when it comes to training elite aviators, preparing them for battle.
A fleet replacement squadron trains the frontline pilots. That's what we do. The folks that we get into VFA 122 have never flown anything tactical, but when they leave here, they go right to a frontline fleet squadron.
To forge elite pilots out of raw aviators, trainers here push their students harder than most other squadrons.
We have roughly 100 students of some type in training at any one time here. We're flying probably more than we expected to, certainly more than anybody else expected us to the tune of 18,000 hours last year alone, where another squadron with a similar mission like this one typically would fly 12 to 13, maybe 15,000 flight hours. To put that in perspective, a fleet squadron on a very good year might fly 5,000 hours.
Since the delivery of the first FA-18s in 1980, Lemoore has been known as the home of the Hornet. Nearly 365 days a year, from the early morning on, the skies over Lemoore echo with the deafening roar of FA-18 jet fighters. The FA-18 that these trainees hope to fly is a much more sophisticated machine than earlier Navy jets. During the 1960s and 70s, the Navy was launching two formidable workhorses from its aircraft carriers. The F-4 Phantom was a reliable, fast, powerful fighter designed for air-to-air combat. Capable of reaching speeds of almost 1,500 miles per hour, it could carry a deadly array of weapons. The A-7 Corsair was a slower armored jet, a lethal light bomber that could deliver a 15,000-pound payload. Combined, the two planes flew hundreds of thousands of combat sorties in military operations all over the world. But by the mid-1970s, the F-4 and A-7 were aging and nearing the end of their useful lives. The Navy needed newer, higher-tech aircraft able to handle the demands of modern warfare. The Navy conceived of the FA-18 in order to replace both the F-4 and A-7 in one combined strike fighter design and thereby free valuable space on its aircraft carriers. As a result, the FA-18 is the first jet designated both F for fighter and A for attack. The deployment of a multi-role strike fighter had been a long-time goal for the Navy, and the FA-18 has fulfilled that goal and more. While past planes like the F-4 could be configured as either a bomber or a fighter for a single mission, the FA-18 can fill both roles simultaneously.
The beauty of the F-18 is that you can carry a number of weapons across the wing, 6, 7, 8 weapons that can all be independently targeted on separate aim points in a target area. In the past, you may have needed, a whole strike from a carrier to be able to do that. Now you just do it with one airplane.
The FA-18's multi-role capability has made it the mainstay of the carrier air wing. And like all Navy planes, it still has to meet the tough requirements of fleet aviation. On the deck of an aircraft carrier, FA-18s undergo constant structural stress caused by the violence of landing. But they're built to take it.
I think what you'll notice, versus an Air Force aircraft, is just look at how beefy the landing gear are on any Navy airplane. And that's just to withstand the shock of coming down at about a descent rate of 750 foot per minute rate of descent, flying that 3-degree or 3.5-degree glide slope. The landing gear is built to withstand that shock.
With 15 years of FA-18 experience, Dan Dino Martin knows full well the challenges of fleet aviation. He's successfully touched down on carriers over 400 times. Landing an FA-18 is the equivalent to bringing a loaded semi-trailer from 150 miles per hour to a full stop in less than 3 seconds. The FA-18 is also built to sustain a punishing takeoff.
Another thing you'll notice about the aircraft, the nose gear is going to be real beefy, but what's this ugly-looking thing right here hanging off the front of the nose gear? That's our launch bar, and that is going to be hydraulically extended and retracted. It goes down into that shuttle, it goes down a cat track, and that shuttle grabs onto the tip of that launch bar, and that's what propels you down the catapult stroke.
Powerful engines, General Electric's F-404s, are each capable of generating 18,000 pounds of thrust, an astounding 1/4 of the thrust of the rocket that sent the Mercury spacecraft into orbit. The FA-18's twin engines have built-in redundancy, so that if one engine goes down, the other can power the plane. Despite all the extra weight needed to land, launch, and keep the F-A-18 aloft, its power and small size make it the most maneuverable aircraft in the Navy's airborne arsenal. Racing at top speeds of Mach 1.8, the Hornet can also climb at a rate of over 45,000 feet per minute. Leading-edge wing extensions and outward-canted tail fins stabilize airflow, while the wide range of motion in the ailerons, flaps, and tail planes give the Hornet unparalleled pitch and roll control. The F-A-18 is so maneuverable, it's the jet of choice for the Navy's Blue Angels demonstration squadron. These daring pilots have been flying the F-A-18 Hornet since 1986. The jet's speed and handling characteristics have allowed the team to add new maneuvers to their program. The F-A-18 can turn on a very tight radius and perform rapid rolls, all while also displaying the best slow speed ability of any Navy jet. But the Hornet's maneuverability takes a physical toll on the pilot. Its high-speed turns can create over 7.5 Gs. Under this stress, the average pilot feels almost 1,500 pounds of downward pressure on his body. To prepare for the rigors of flying an F-A-18, pilots at Lemoore Naval Air Station undergo intense training. One of the most grueling stages takes place in the centrifuge. Lieutenant Tori Campbell is the Director of Navy and Marine Corps Centrifuge Training. All new F-A-18 pilots must make it through her program before being cleared to take off in the jet.
So what we have today is a very typical class for Centrifuge-Based Flight Environment Training, or CFET. We have 10 students. They are new F-A-18 pilots. They are winged. They are already pilots, but they are just beginning to learn how to fly the F-A-18. We're bringing them through this training. They get it at the very beginning of their training to teach them how to deal with the effects of the Gs, because the F-A-18 is by far the most capable aircraft that these young pilots have ever flown in.
The goal is to teach the trainee how to handle the high Gs while pursuing an enemy or bandit. The centrifuge contains an exact replica of the pilot's controls.
During this training, the pilot is actually controlling the device from inside of it. It's a 90-second profile. It's extremely challenging as the pilot has to go ahead, track the bandit, and at the same time perfect this technique to enable him to go as high as 7.5 Gs.
Failing to master the anti-G maneuvers can be disastrous.
If at the point that the pilot begins to experience gray out and he does not correct the situation by improving his anti-G straining maneuver, this can progress to G-lock, which is gravity-induced loss of consciousness. During a G-lock event, the pilot is completely unconscious. Typically it's about 12 seconds, but it can be as long as 45 seconds. Probably even more dangerous than the G-lock is the A-lock, or the almost loss of consciousness. After an A-lock, the pilot, although having never lost consciousness, is completely confused, disoriented, and has no sense of spatial awareness. The lights are on, but nobody's home, and this is extraordinarily dangerous.
The high Gs pulled by the F-A-18 make time spent in the gondola critical.
This is an extremely important part of their training. A lot of the training, the survival training that pilots get, is only if something goes horribly, horribly wrong. But for an F-A-18 pilot, the skills and techniques that they're going to learn here today are things that they will use every single time they fly their aircraft.
Go ahead and step up here, sir.
To counter high Gs, pilots flex their core muscles and exhale sharply in what's called a hic maneuver for the sound the pilot makes. They also wear specially engineered G-suits.
What the G-suit does is when you're pulling Gs, basically it's pushing all the blood to the lower parts of your bodies, the lower extremities such as your thighs, your calves, and your abdomen, and it brings the oxygenated blood away from your brain. So what this does is create pressure around the biggest muscles, and also incorporated with the hic maneuver, the squeezing of your lower extremities, your biggest muscles being the thighs and abdomen. It pushes all that blood back up and keeps you from passing out.
I'm just going to have you sit here, sir. I'm going to take a look at your AGSM. Okay. So I know what's going to happen inside the gondola.
This F-A-18 pilot in training is about to undergo the centrifuge's ACM profile. It's by far the most grueling. He practices his anti-G straining maneuver one last time.
Any questions? No. Looks good. Okay, and I'll get somebody to put you in.
Great. Go ahead and follow me, please.
Personnel in a control room monitor his breathing and blood pressure levels and watch for G-lock and A-lock symptoms.
Comm check, please.
Loud and clear, how me?
Read you the same, loud and clear.
Restraint system?
All 4 locked.
But even with all the safety checks, once the door closes, he's on his own.
G-suit?
Plugged in, comfort zipper zip, no air first drive. All right, pilot is clean. Gondola is clean.
Yes, sir, you ready to go to idle? Yes. It's gonna be about 15 seconds till you feel it start moving. Breath?
The initial stages of the profile hover between 5 and 6 Gs, with breaks of minimum G tolerance in between. Then the pilot is taken to the FA-18's maximum G-force level.
Rest up as much as possible. This next peak is 7.5. I want you to pull the stick back and get on top of the G's as quick as possible. Bites on, get a good prep, 7.5. Keep it in, bury that stick, back, 3, 2, get him in the middle, sir. Hold it off, sir. Lock it off. Seal it off, sir. Breathe. Coming down this time, follow him down.
Today, the pilot maintains consciousness, but even the toughest aviators will feel the effects for as long as 12 hours, and this trainee will have to endure at least 2 more profiles before he's certified.
You can really feel like all the pressure going like out of your head and chest, down into your legs, and you start straining, you know, you can see the lights start to come back on a little bit, but to keep working that hard to see is really tough. In an F-18 Hornet, it's really important to be able to understand how this training works, using the G-suit and the centrifuge, and understand how your body reacts to Gs, because you could be fighting somebody one-on-one in a real dynamic environment where you're pulling a lot of Gs and trying to look out over your shoulders and maintain a good look at so you can see the bandit. Or if you're coming off a target and you have to snatch on a bunch of Gs real quick, then you need to know how to prepare your body so you don't black yourself out or go unconscious and put yourself into some real danger.
To maintain control during the most difficult maneuvers, the FA-18 contains a computer-assisted fly-by-wire system. Some pilots say it makes operating a plane more like a video game than traditional flying, but its impact on safety and handling is very real.
The F-18 is a fly-by-wire aircraft. In other words, as a pilot in the cockpit, you are merely a voting member of the flight control system. 2 flight control computers analyze inputs, digital inputs from the cockpit, from stick and rudder inputs, and then transfer that information to hydraulic actuators back here in the flight control surfaces to give you what you want. Merely a left turn isn't like in a Cessna where the ailerons, you know, rise to meet you. In other words, a left turn here, this aileron's going to come up and that aileron's going to go down and we're going to turn left. Well, that may not necessarily be the case in an F-18. The flight control computers are going to say, okay, he's going this fast and he wants to go left, so I'm going to move these surfaces this way to give him what he wants.
The FA-18's fly-by-wire control takes the pilot's stick and rudder movements and interprets them. Separate computing systems evaluate the input and instantaneously decide what surfaces to move. If more than 2 of the computers fail, the pilot can manually take back some critical controls. If the pilot does lapse into G-lock during a maneuver, the FA-18's flight system takes over, automatically leveling out the jet's path through the air. This highly advanced flight system is just one of the striking contrasts between the FA-18 and other carrier-based fighters past and present. Perhaps the most legendary is the F-14 Tomcat. In speed, range, and sheer muscle, the F-14 is unmatched in naval aviation history. This fast, powerful jet was known as the king of the carrier deck for over 30 years. The last of the Tomcats came off the assembly line over a decade ago to be replaced by the more advanced FA-18. Compared to the Tomcat, the smaller, leaner Hornet almost looks fragile. But the F-A-18 is anything but dainty. Since its first deployment, this powerful jet has flown thousands of successful combat missions. One of the F-A-18's greatest strengths is its reliability. The F-A-18 contains 50% fewer parts than the F-14. And fewer parts means the plane is easier to maintain. One floor down from the flight deck is the hangar deck. This is where planes go when they are in need of work. Off the hangar deck, crews specialize in getting grounded planes back into action.
Right now we're back here in the jet shop where I've got about 40 people that do work on the various engines that we have the capability to repair. This engine behind me here is an F404. It's the engine that's out of the F-A-18 Hornet. We've done some maintenance to this. It's in a modular format where we can remove any of the modules on the engine, replace them, run the engine across the test cell, and then it's ready to be issued back out to the squadrons again. So these gents are making that ready to go.
The F-A-18 has proven even more dependable than the Navy hoped, especially when compared to the F-14 Tomcat.
The Tomcats, as you well know, are aging, and they're aging rather fastly, so they require more maintenance man-hours per flight hour than, say, the Hornet. The Hornet, on the other hand, is still relatively young, comparatively speaking, and there aren't as many maintenance man-hours required.
Tomcat maintenance squads must work almost 4 times as many hours to maintain their aging aircraft. When not undergoing repairs or routine maintenance checks, carrier-based F-A-18s are either in the air or parked, wing to wing, on the flight deck. With as many as 80 planes aboard, and several at a time taking off or landing, the flight deck can become dangerously busy. F-A-18 pilots rely on experienced flight deck operators to move their planes from one spot to the next. With the amount of activity on the flight deck, pilots and personnel have to be under constant alert.
Some people like to say that it's one of the most dangerous streets in the world because of everything that's going on. You really have to have your head on your shoulders and be thinking about everything that's going on around you. There's so much going on and so much danger and bad things that can happen, so it takes a lot of skill.
With all the heavy moving parts, one wrong turn can spell disaster. F-A-18 pilots have to make sure they're constantly on the same page with their operators, communicating with them using a strict system of signals. To make room on the crowded deck, all naval planes, including the F-A-18, are designed to take up as little space as possible.
All aircraft that come to the Navy, there is a requirement when they are designed to have some type of function where they can minimize their surface area on the deck. And that means, even down to a helicopter that is going to fold its rotor blades all the way back. The Tomcat's wings will sweep all the way back rather than coming out for the takeoff position that they need. On the S3 wings that fold over the top and now crisscross over the top of the aircraft because that is a very large wing aircraft. But on the F-18, we're going to fold these wings upright, and now there's an extra 4 to 5 feet of space, 10 feet total now with the other wing, where that is space not utilized on the flight deck anymore. In other words, able to be used for the guys moving, taxiing aircraft around.
With $38 million worth of machine under their control, the operators gently ease the F-A-18s into their spots. Once in place, another crew chocks the wheels and chains down the plane. They're all following a well-ordered parking plan, a plan monitored just off the flight deck. Once an F-A-18 touches down, it becomes the responsibility of the handler.
Heads up around the island, pulling out a prop. Heads up around 643.
The handler keeps track of the plane's position and uses a complicated set of push pins and buttons to update each plane's status. The aircraft templates are exactly to scale, even down to the area a helicopter's props take up when spinning. Precision like this is essential, as the slightest miscalculation in timing or aircraft size could cause a deadly mishap. One of the most important jobs is to monitor when a jet is low on fuel. Before an FA-18 can be cleared for launch by the handler, its tanks have to be filled. Fueling and defueling the jets is a specialized task handled by a meticulously trained crew. And they're kept busy with the FA-18s, which consume massive amounts of fuel, also known as JP-5. One criticism of the FA-18 is that it has a relatively small onboard fuel capacity of 1,600 gallons. To increase its range, it can carry 3 external tanks.
You've got 3 drop tanks, which holds about 330 gallons worth of fuel, or 2,200 pounds. So just by adding those 3 tanks, we increase our fuel load by 6,600 pounds. We add the drag, but the amount of gas that we get outweighs the drag of pushing those through the air.
Including its internal tanks, the FA-18 carries roughly 2,500 gallons of JP-5. On a regular patrol, it can use almost all its fuel in just an hour and 45 minutes. And FA-18s really burn through their fuel on takeoff, and when they need sudden acceleration from their afterburners. The blast from an FA-18's afterburners is so hot, the protective jet blast diffractors on the flight deck are made of reinforced concrete, as metal would simply melt.
With the afterburner, the hot gases that leave the turbine section are incredibly hot, so by throwing just fuel onto those hot gases, right, you get an instantaneous ignition. By opening these turkey feather nozzles, you allow those gases to leave at a very rapid rate, which results in a tremendous burst of acceleration. If I plugged in the afterburners, I'd probably be out of fuel in about 15 to 20 minutes.
To keep the FA-18's hungry engines well fed, the carrier needs to keep a large supply of JP-5 on hand. There's so much fuel on board, it serves as ballast to steady the ship and keep the flight deck level. Over a 6-month period, a carrier's planes can burn through almost 12 million gallons of JP-5. To keep the jets fully fueled, the carrier rendezvous with a supply ship every 7 to 10 days. Fully fueled and operational, a carrier's FA-18 squadrons can fly over 100 sorties per day. On mission, or as pilots say, in country, the first order of business for FA-18s is to defend against air-to-air targets. This is what's known as dogfighting, and it's an arena in which the FA-18 has proven highly successful. Close combat is a modern duel to the death, and dogfight training is among the most intense phases of learning how to fly the FA-18.
What I'm going to try to do is to stay on your tail as best I can today.
At NAS Lemoore, trainees have to take on their instructors to earn their FA-18 certification.
We will get ourselves to the appropriate...
Lieutenant Commander Mike Bossard is in charge of the fighter weapons phase of FA-18 training. Today, he is training a former Tomcat pilot how to effectively maneuver the FA-18 in every dogfight scenario.
And once I get to the appropriate range, I'm going to call either a missile shot or I'm going to call fights on. So if you ever lose sight of me today, just look right at your 6 o'clock position and I'll probably be right there.
Or you hope so.
What do you say we go out there and have some fun?
Sounds good.
The dogfighting stage marks roughly the halfway point in FA-18 training, combining what trainees learned in class with high-G maneuvering. This is also the time when new pilots first challenge their instructors. Their game faces on, teacher and student prepare to square off. Before takeoff, the pilots personally ensure their jets are in working order. For the high-speed maneuvers of dogfighting, pilots need to be certain their jet will perform flawlessly under even the heaviest G-forces. All flaps, ailerons, and stabilizers are tested. dogfighters taxi out, and the duel begins. When they're on the offensive, pilots need to stay on the tail of their adversary and lock on target.
Trigger down, snap.
Defensive maneuvering requires severe G-turns and sudden escape moves.
Right. I got sight. Knock it off.
In the last exercise, the trainee proves his mettle, turning the tables and getting on his instructor's tail.
That was sneaky. See ya.
But he must still complete weeks of additional weapons training before he is certified to drop live ordnance. Among the FA-18's most lethal air-to-air weapons is the Raytheon AMRAAM, or Advanced Medium-Range Air-to-Air Missile. The AMRAAM is capable of being launched at well beyond visual ranges, in any weather, day or night. Its low-smoke, high-impulse rocket motor reduces the chance of enemy sighting and evasion, while its 45-pound warhead can take out any plane in existence. The AMRAAM's self-contained active radar seeker allows the FA-18 pilot to maneuver immediately after launch without disrupting the missile's path to its target. Just as deadly as the AMRAAM is the AIM-9X Sidewinder. The Sidewinder's strength is for shorter ranges than the AMRAAM. Its tracking device features a 180-degree periscope-like infrared seeker that can spot and chase targets. The AIM-9X earned the name Sidewinder with its vectoring rocket motors, which allow right-angled turns. Pilots fire and sometimes even steer these weapons from the FA-18's cockpit. What makes these weapon systems all the more lethal is a cockpit design with a heads-up display that allows the pilot to perform many functions without looking down. And almost every task a pilot needs to perform can be done without having to take his hands off the controls.
Well, the biggest thing to note is hands-on throttle and stick, or HOTAS. I mean, everything, you can do everything with just with your fingers while they're on the stick and throttle. Where the Tomcat was more user-intensive, had to push a lot of buttons, take your hands off the throttle or take your hands off the stick to do certain things. And in the front of the Tomcat, you had very limited capability as far as what kind of radar modes you were in and what kind of stuff you could do. The Hornet, from the front, you basically can do everything.
With the FA-18's advanced cockpit design and fly-by-wire control system, the pilot has more flexibility than in any other Navy jet.
What this aircraft becomes when you go airborne, or even prior to going airborne, it becomes more or less an extenuation of your actual body. I mean, you become a part of this jet, you become one with the jet. What these displays allow you to do is find a mechanism or a conduit through which you can best glean all that information off, and you can incorporate that into your decision-making process while you're airborne. You get very comfortable hopping into this thing, starting it up, and launching off the front end of the carrier with it.
To get this comfortable with their planes, future FA-18 pilots spend over 50 hours in a flight simulator at NAS Lemoore. It recreates almost exactly the cockpit and flight characteristics of the FA-18. This state-of-the-art equipment enables air crews to virtually fly every scenario.
We'll initially start our training here with just basic flight procedures, and as the training progresses, we'll learn different weapon systems, how to fight the airplane air-to-air, and how to use it air-to-ground. And eventually, we'll end up flying at the boat with this.
The final test that future Hornet pilots face in the simulator prepares them for one of the most difficult tasks in naval aviation: landing on the deck of an aircraft carrier.
The minute you take off until you get on the carrier, that's all you're thinking about is that landing. You can't replicate that. The simulator does the best you can, but there isn't the feeling of fear, the feeling of death, or the excitement, or the adrenaline. It doesn't come through your system in the simulator. But what this will do is give you muscle memory. When the adrenaline does start pumping through your body and the excitement, you start thinking about what you did in the simulator.
After simulated carrier landings, pilots get even closer to the real thing. This is Lemoire's landing signal area, complete with arresting cables, distance markers, and even the identical landing lights pilots use as a guide to touch down on the carrier successfully.
Here at NAS Lemoire on runway 32 left at the just outside the LSO shack. Behind me you can see the optical landing system, the Fresnel lens, which provides the pilot a optical reference for how high or low he is below glide slope, and that's real important because the plane has to land at the proper spot on the carrier. The LSO, landing signal officer, he stands at the back of the boat, and he's in verbal communication with the pilots via the radio. But he also uses this, the pickle. This controls the lens. Pushing this button illuminates the red wave-off lights. So that would indicate that the landing area is fouled, like there's another aircraft in there or personnel. And also the cut lights here, you can give them by using the cut lights, it's another non-verbal way that the LSO can communicate to the pilot that he wants them to give a little bit of power to come up on glide slope a little bit.
The runway at Lemoire's Reeves Field stretches for 13,500 feet, giving pilots plenty of landing room. On a Nimitz-class carrier, the landing strip is just 500 feet long. To bring an FA-18 to a complete stop, the pilot has to grab or trap one of 4 arresting cables. That means dropping the plane into a 40-foot box, ideally just 2 feet in front of the wire. Without some sort of arresting device, the jet would skid right off. Dropping 800 feet in just 15 seconds, the pilots have to keep the plane's nose up and maintain the correct attitude or angle of descent. Flying in at a minimum of 150 knots to avoid engine stall, FA-18 pilots aren't so much landing the plane as aiming it at the wire. As soon as he touches down, the pilot revs his engine in case he slips the wire. If he misses, he takes off, circling around to try again. During the day, the pilot can at least see the deck. At night, the carrier turns off all but a few lights to avoid becoming an easy target for enemies. Liquid vapor torches cast just small pools of light. The rest of the flight deck remains as dark as possible. From 3 miles away, the carrier looks like a pinprick of light. There's no way to tell which direction it's moving, and a fatigued pilot's eyes can easily play tricks on him. Pilots returning at night have often been aloft on missions as long as 6 hours. The extra fatigue leads to a greater chance of missing the wire.
You're fatigued. You've had a lot of excitement, adrenaline high, adrenaline low, probably hungry, tired, all that. At night, you don't really look at the carrier except for maybe the last 10 seconds of the approach or something like that. It's just an instrument approach. You have a set of needles, one for lineup, one for glide slope, and you're just keeping those things centered up. Like magic, there's the boat, and you just fly a touchdown. So it's all instrument work, pretty much. And if you keep that thing centered and you keep the attitude on the jet, then you'll grab a 3-wire every time.
Day and night, FA-18s and other planes are watched closely in the Air Traffic Control Center, a miniature version of what exists at any major airport. At the very top of the tower, the air boss directs the landings and takeoffs. From his perch, the air boss oversees pilot landings on the aft of the flight deck, as well as launches on the middle 2 catapults. His assistant, the mini boss, oversees the front, where the 2 most active catapults are. All information about the carrier's FA-18s from launch to landing goes through the air boss. It's his job to deal with information, occasionally jotting notes on the wall and windows to keep it straight. He then relays the critical information to wherever it needs to go. The air and mini boss are both aviators. This way they know every procedure intimately and immediately understand a pilot's status. Even the captain of the carrier is an aviator, highlighting the role of the aircraft carrier as a floating airbase. The F-A-18's central role on the carrier is clear from the top of the tower to deep into its belly. This is one of the ship's 40-plus weapons magazines, where crews prepare the F-A-18's various weapons loads.
What we're doing today is configuring two Mark 83 low-drag bombs, utilizing a parachute-type fin assembly. What they're going to be doing now is they're going to hoist the bombs up on the bomb table.
This 1,000-pound ordnance is a dumb bomb, just one weapon in the F-A-18's arsenal. The F-A-18 can be configured to carry over 24 different bombs and missiles. Once the F-A-18's bombs are assembled, they ride a series of elevators to the flight deck. Here, the ordnance comes under the control of weapons inspectors. They wheel the bombs over by hand before attaching them to the F-A-18's pylons. For all the high-tech gadgetry surrounding the F-A-18, some tasks still come down to raw muscle power. Although the bomb is not yet armed, it does contain almost 1,000 pounds of explosives. In past carrier disasters, fires have ignited the aviation fuel, which then set off the bombs. Today's bombs have extra insulation so that they can withstand short periods of extreme heat or fire. The last step is to add the fuse. The final arming of the bomb takes place only after the plane takes off. From inside the F-A-18 cockpit, pilots throw a switch, activating them. Dumb bombs are just a small part of the F-A-18 strike-ready arsenal. For precise ground support, they include the latest laser and GPS-guided weapons.
Everything we're doing in country is precision-guided munitions. In other words, a laser-guided bomb or a bomb that goes to precision coordinates on the ground.
One of the F-A-18's most lethal air-to-ground weapons is the JSOW. A large precision strike weapon, the JSOW affixes to the F-A-18's middle wing weapon station. Once launched, it releases two wing structures that allow the missile to glide toward its target. Skimming just a few feet above the ground, the JSOW releases powerful cluster bombs that can destroy multiple targets in one strike. Equally lethal, but with different capabilities, is the HARM, or High-Speed Anti-Radiation Missile. Accurately hitting targets from well beyond visual ranges, HARM destroys enemy radar before the F-A-18 can even be detected. The F-A-18 can also be equipped with Maverick, SLAM, and Shrike missiles, as well as a host of guided and unguided bombs. The highlight of air-to-ground weapons training is when F-A-18 pilots learn what it's like to drop real live ordnance. Flying missions over remote testing areas, pilots take full control of the F-A-18's precision strike capabilities, pinpointing designated targets and releasing fully armed bombs. Known as Live Day, this is when new Navy pilots experience for the first time the destructive air-to-ground capabilities of the F-A-18. What makes the F-A-18's weapons so lethal is the latest in targeting technology. Carrier-based Hornet squadrons increasingly employ deadly accurate infrared systems
This is a forward-looking infrared pod that the Navy F-18 carries, and what we do with that thing is now we are able to look via that sensor onto the ground to a specific target point, find a building, maybe even an urban environment. Now I can turn on some laser energy withheld in that pod, laser designate that target, and now my laser-guided bomb goes to that laser energy, and now I get a probability of impact within about 13 feet.
FA-18s also track targets using highly advanced radar technology, housed in the nose of the plane. These unique systems allow the pilot to switch between air-to-air and air-to-ground modes with the push of a button. Integrated into an electronic network, the FA-18 takes on a central role in frontline operations. Through satellite data link, the radar, map, and weapons displays of the FA-18 cockpit can be seen by fellow aircrew, as well as commanding officers in the carrier strike group. The frontline FA-18 becomes the eyes and ears of an integrated battlefield. And with each updated model, the FA-18 grows more sophisticated. At Lemoore, the latest class has spent 9 months preparing for battle. As they set out for the fleet, the most recent graduates take control of the next generation of FA-18, the Super Hornet. The Super Hornet design is based on the original FA-18, but it is an even more lethal machine. The Super Hornet is almost 3 feet longer and has a 25% larger wing surface than the A through D models. Its structural differences include diamond-shaped intakes and a dog-tooth wing design. The bigger, stronger Super Hornet holds 35% more internal fuel capacity and contains extra space for future technologies. On its longer wings, the Super Hornet can support 2 additional weapon stations or fuel tanks.
Well, of course,